Have you ever wondered what the sun sends our way besides light and heat? There's an invisible stream flowing from it, a cosmic river of energy and matter. This is the solar wind, a constant outflow of charged particles, mostly electrons and protons, ejected into space. The solar wind is a powerful force, shaping planets, creating auroras, and even impacting our technology. In this video, we'll uncover 10 surprising facts about the solar wind, how it paints our skies, disrupts our tech, and extends the sun's reach far beyond the planets. Get ready to dive into the science behind this invisible force and discover how it connects us directly to our star. Let's get started. So, what exactly is the solar wind? What is this constant outflow that emanates from our star? It's not like the wind we feel here on Earth, it's a plasma, often referred to as the fourth state of matter. A state where matter is so hot that electrons are stripped from atoms, forming an ionized gas. Deep within the sun's corona, the outermost part of its atmosphere, atoms are ripped apart by the intense heat. This process creates a superheated soup of electrons and protons, constantly swirling and interacting. This plasma is overwhelmingly composed of hydrogen, the most abundant element in the universe. But it also contains traces of helium, the second most abundant element, a lighter gas that also contributes to the solar wind's flow, and smaller amounts of heavier elements like carbon and oxygen, all contributing to the complex composition of this outflow. Therefore, studying the solar wind means studying the sun's own material, ejected and blasted into space at incredible speeds. As it reaches the vicinity of Earth, the solar wind is incredibly diffuse, spread thin, with just 5 to 10 particles per cubic centimeter. But despite its seemingly low density, it's packed with an immense amount of energy and travels at astonishing speeds. The solar wind is primarily driven by the corona's extreme temperature, the source of its power and constant acceleration. That temperature soars to over 1,000,000 degrees Celsius, an almost unfathomable level of heat. At these extreme temperatures, the sun's immense gravity simply can't hold on to the superheated particles. As a result, they escape the sun's pull, streaming outwards and creating a vast bubble known as the heliosphere. So, let's remember fact number 1. The solar wind is a plasma, a continuous stream of charged particles. It's not just something separate from the sun. It's a direct and constant extension of the sun itself. In essence, it's the sun's atmosphere expanding outwards, permeating and filling the entire solar system. Therefore, we are, quite literally, swimming in the sun's outer layers, constantly bathed in its energetic breath. This cosmic wind creates a fundamental connection, linking us to our star in ways that we're only beginning to fully understand and appreciate. And its speed, reaching hundreds of kilometers per second, is just as astonishing as its origin and composition. The solar wind isn't just fast, it's a constant stream of charged particles. It's a cosmic speed demon, a relentless force emanating from our sun. These particles are always on the move, constantly bombarding everything in their path. There are 2 main types of solar wind, each with its own distinct characteristics and origins. These are known as the slow and fast solar wind. They differ significantly in speed and density. The slow wind, originating from the sun's equatorial regions, moves at a considerable pace of 300-500 kilometers per second. That's about 1,000,000 miles per hour, a speed that's hard to truly comprehend. Imagine the force behind that. The fast wind, on the other hand, emanates from coronal holes near the sun's poles. These coronal holes are regions of open magnetic field lines. This fast wind can reach speeds of up to 800 kilometers per second. That's nearly 2,000,000 miles per hour, an absolutely blistering pace. It's faster than most rockets. These open magnetic field lines act like nozzles, channeling and accelerating the plasma. They are effectively blasting plasma into space at incredible speeds, creating the fast solar wind. As the sun rotates on its axis, these streams of solar wind are constantly being emitted. The fast and slow streams sweep over the planets in our solar system, interacting with their magnetic fields and atmospheres. This creates a constantly changing space environment, a dynamic interplay of solar energy and planetary defenses. One day, Earth might find itself bathed in a gentle stream of slow solar wind, but the next, it could be slammed by a high-speed jet of particles, leading to significant space weather events. Fact number 2 about the solar wind. The solar wind travels at incredible speeds, reaching up to 800 kilometers per second at its fastest. And as it hurtles through space, it's carrying immense energy, a constant outflow from our sun. Its velocity is what gives it the power to shape planets' magnetospheres and even strip away their atmospheres over billions of years. The solar wind can also significantly affect spacecraft, disrupting communications and even damaging sensitive electronics. Ultimately, it is a major driver of space weather, influencing everything from auroras to geomagnetic storms. The sun's wind is anything but gentle. It's a powerful and dynamic force. It's a constant reminder of the star's raw power and its influence on the entire solar system. And when it reaches Earth, after its long journey through space, the results can be truly spectacular, painting the sky with breathtaking auroras. Let's delve deeper and see exactly how this happens. When the solar wind reaches Earth, our magnetic field acts as a shield, deflecting most particles. But near the poles, some particles slip through, spiraling down into the upper atmosphere. There, they collide with oxygen and nitrogen, exciting atoms and creating flashes of light, photons. Billions of these collisions produce the auroras, the northern and southern lights. Different gases and altitudes create the aurora's colors: green from oxygen, blue and purple from nitrogen. Fact number 3. Auroras are the visible result of the solar wind's dance with Earth's magnetic field. It's a cosmic light show, powered by particles that travel 93 million miles. The solar wind's energy isn't always beautiful. It can threaten our technology. Strong bursts, like those from solar flares or coronal mass ejections, can disrupt satellites, causing data loss or damage. GPS signals can be scrambled as the solar wind disturbs the ionosphere, reducing accuracy or causing outages. Satellite communications, TV, and internet services can be interrupted. Even astronauts must take shelter during major solar storms to avoid dangerous radiation. Fact number 4. The solar wind can disrupt satellites, GPS communications, and pose risks to astronauts. As we rely more on technology, understanding and predicting space weather becomes critical. The sun's invisible wind is a force we can't ignore, but it also shapes the cosmos in other ways. Let's look at comets. The solar wind's influence is visible in comets. As a comet nears the sun, it develops two tails: a dust tail and an ion tail. The dust tail is pushed by sunlight, but the ion tail is shaped by the solar wind. Solar wind sweeps ionized gas straight away from the sun, creating a long bluish tail. No matter the comet's direction, the ion tail always points away from the sun. Fact number 5. The solar wind sculpts a comet's ion tail, making it a cosmic weather vane. If you see a comet, its ion tail shows you the direction of the sun's invisible breath. The solar wind's reach is vast. So how far does it go? Let's find out. The solar wind creates a giant bubble around our solar system, the heliosphere. Far beyond Pluto, the solar wind slows at the termination shock, then enters the turbulent heliosheath. The final boundary, the heliopause, is where the solar wind's pressure balances with interstellar space. Beyond the heliopause, you're in interstellar space. Voyager 1 and 2 crossed this boundary, becoming our first interstellar explorers. Fact number 6. The solar wind defines the boundaries of our solar system. The heliopause marks the end of the sun's direct influence. A vast bubble carved out of the galaxy. The solar wind's journey tells us where our solar system truly ends. Studying the solar wind lets us study the sun itself. We can't visit the sun's surface, but the solar wind brings its material to us. It carries the sun's magnetic field, known as the interplanetary magnetic field, across space. By analyzing the solar wind's composition and magnetic structure, scientists learn about the sun's corona and magnetic dynamics. Fact number 7. The solar wind is a cosmic messenger, revealing secrets of the sun's magnetic field and corona. Every particle is a clue to the sun's inner workings. Our understanding of the sun depends on this invisible wind, but sometimes the wind becomes a storm. Sometimes the sun unleashes massive eruptions, coronal mass ejections, that send shock waves through the solar wind. When these hit Earth, they trigger geomagnetic storms, compressing our magnetic field and letting solar particles pour in. These storms can induce currents in power lines, causing blackouts, like the 1989 Quebec outage. Pipelines and radio communications can also be affected, and auroras can appear far from the poles. Fact number 8. Enhanced solar wind can cause powerful geomagnetic storms, threatening power grids and infrastructure. The infamous Carrington event of 1859 set telegraph systems on fire. A similar storm today would be catastrophic. The solar wind storms are a reminder of our vulnerability. But how did we discover this invisible force? For centuries, space was thought to be empty. The idea of a solar wind was just a theory until the space age. In 1958, Eugene Parker predicted the solar wind's existence. The first direct detection came from the Soviet Luna 1 mission in 1959, followed by Mariner 2 in 1962. These spacecraft confirmed a constant stream of particles from the Sun, matching Parker's predictions. Fact number 9. The solar wind was only confirmed by spacecraft in the late 1950s and early 1960s. This discovery launched the field of heliophysics and changed our view of space forever. Now we're not just detecting the wind, we're flying into it. Here's how. To truly understand the enigmatic nature of the solar wind, a constant stream of particles emanating from our star, we realized we had to venture closer, right to its very source. NASA's ambitious Parker Solar Probe, a marvel of engineering, launched in the year 2018, embarked on a daring journey, is now fearlessly flying directly through the Sun's fiery corona, its outermost atmosphere, protected by a revolutionary heat shield capable of withstanding extreme temperatures. It's not only incredibly resilient, but also the fastest object ever built by humankind, coming within a mere 6 million kilometers of the Sun's scorching surface, a distance previously thought impossible to reach. In 2021, a historic milestone was achieved. It became the first spacecraft to touch the Sun, venturing into the solar atmosphere, directly sampling the solar wind at its origin, gathering invaluable data about its composition and behavior. The probe is revealing groundbreaking new details about the processes of coronal heating and the mechanisms behind solar wind acceleration. Fact number 10. We are now actively studying the solar wind up close and personal, thanks to the remarkable capabilities of the Parker Solar Probe. This groundbreaking mission is fundamentally rewriting our understanding of the Sun, its dynamic processes, and the nature of its ever-present wind. From theoretical models to direct in situ exploration, we are finally, after centuries of speculation, touching our star and unlocking its secrets. And the captivating story of the solar wind and its influence on our solar system is still unfolding, with many more discoveries to come. 10 surprising facts reveal the solar wind as a powerful dynamic force connecting us to our star. It creates auroras, shapes comets, defines the solar system's edge, and impacts our technology. Studying it, from early probes to the Parker Solar Probe, teaches us about the Sun and our place in the cosmos. The solar wind is a constant reminder that space is alive with energy and matter. If you enjoyed this journey, subscribe for more cosmic discoveries. Until next time, keep looking up. Before you go, become part of our cosmic community. Hit that bright red subscribe button to catch every new space adventure. Give this video a thumbs up if you loved exploring the solar wind, and let us know your thoughts or questions in the comments below. Your voice shapes our next journey. Don't miss out on the wonders of the universe. Subscribe, like, and join the conversation today.